In this video, we're putting Deepseek R1 to the test with a simple mapping task to see how well it performs. If you haven't heard yet, Deepseek R1 is a powerful large language model that's making waves online, being seen as a direct competitor to OpenAI's ChatGPT. But does it really live up to the hype? Stick around until the end, because we'll not only see the results, but also compare how it stacks up against other AI models. Setting up the test. To start, I'll fire up Deepseek R1 by heading over to chat.deepseek.com. One of the great things about Deepseek is how easy it is to use. No need for complicated installations, API keys, or advanced setup. Just open the site, type in your request, and let the AI do the heavy lifting. Now, let's put it to the test with a straightforward but insightful challenge, plotting the 20 most visited cities in the world on an interactive map. But I don't just want a basic list of names. I want to take things a step further. The map should be fully interactive, meaning that clicking on any city should display its name, global ranking, and total number of visitors. This way, we don't just get raw data, we get a dynamic visual representation of global tourism trends at a glance. For this, I'll be using Python in a Google Colab environment, and here's why. Google Colab is a free cloud-based coding tool that runs everything online, so there's no need to install Python or any extra libraries on your computer. All you need is a Google account. Just log into Google Drive, create a new Colab notebook, and you're good to go. This makes it super accessible, whether you're a seasoned developer or just experimenting with AI-powered automation for the first time. But here's where it gets even more exciting. Deepseek R1 isn't just executing a pre-programmed task. It's actually analyzing, retrieving, and organizing real-time data, meaning that if rankings or visitor numbers change, the AI can adapt on the fly. Plus, it handles the entire coding process, from gathering the right datasets to structuring the code properly. So instead of spending hours researching, cleaning up data, and troubleshooting errors, we'll see if Deepseek can do it all with just a simple request. So will Deepseek be able to generate accurate, functional code on the first try? And how does it compare to other AI models like ChatGPT? Stick around, because we're about to find out. Key features of Deepseek are: one of the most powerful features of Deepseek R1 is its built-in web browsing capability. Unlike many AI models that rely only on pre-existing training data, Deepseek can search the web in real time, ensuring that it provides the most up-to-date information available. Just like the paid versions of ChatGPT, Deepseek gives you the option to turn web browsing on with a single click. But here's the kicker: Deepseek offers this feature for free. That means you can access live data without needing a premium subscription. Now, why does this matter? AI models trained on static datasets can quickly become outdated. For example, if you ask a regular AI model to list the most visited cities in the world, it might pull information from a database months or even years old. But with Deepseek's web browsing, the model can instantly search for the latest rankings, retrieving information from news articles, tourism reports, and other sources. This makes it an incredibly useful tool for research, business, and even everyday problem solving, whether you're checking market trends, planning a trip, or simply satisfying your curiosity. But that's not all. Deepseek R1 has another game-changing feature: its advanced reasoning model. We all know that not everything on the internet is accurate. When multiple sources present conflicting numbers or rankings, many AI models simply pick one at random or merge them without verifying which is correct. Deepseek, however, takes a different approach. It applies sophisticated reasoning techniques, comparing data across sources, identifying inconsistencies, and making an informed decision about which information is most reliable. Imagine trying to find out which city had the most visitors last year. One article says Bangkok, another says Dubai, and yet another lists Paris. Instead of blindly picking one, Deepseek analyzes the credibility of each source, cross-references the numbers, and determines the most logical answer. This is particularly valuable for business analysts, researchers, and anyone who relies on accurate data for decision-making. So how does this impact our test? Well, since we're asking Deepseek to fetch live data and process it into a functional Python script, we'll see firsthand how well its web browsing and reasoning abilities work in a real-world scenario. Will it deliver a clean and accurate dataset, or will we run into inconsistencies? Keep watching to find out. Running the task now, let's see Deepseek R1 in action. After providing the instructions, the model quickly retrieves a list of the 20 most visited cities in the world, complete with their ranking and visitor count. But here's where things get even more impressive. Since mapping requires precise latitude and longitude coordinates, Deepseek doesn't just stop at basic rankings. It automatically gathers the geographical data needed for visualization, organizing everything neatly into a pandas data frame. For those unfamiliar, pandas is a powerful Python library used for handling structured data, and Deepseek formats the dataset perfectly, making it ready for immediate use. But it doesn't stop there. The model even suggests using the Folium library, a popular Python tool for creating interactive maps. This means we don't have to manually figure out how to display the data visually. Deepseek already knows the best way to do it and gives us the necessary tools. Think about how much time and effort this automation saves. Normally, to build a similar project, you'd have to manually search for the most visited cities and their rankings, find a reliable source for visitor counts, look up latitude and longitude coordinates for each city, format the data into a structured file or database, write Python code from scratch to map everything. Deepseek does all of this in seconds without requiring any manual data collection. This kind of automation is a game changer for developers, researchers, and even casual users who want to build data-driven projects without spending hours gathering information. Now, the real question is, how well does this generated code actually work? Does it run smoothly, or will we need to troubleshoot? Let's test it out and find out. Implementing in Google Colab now that we have everything ready, it's time to put the code to the test. I'll take the generated script and run it inside Google Colab, a cloud-based coding platform that makes it easy to experiment with Python code without needing to install anything. If you've never used Colab before, think of it as a virtual coding notebook that runs in your browser. All you need is a Google account and you're set. No complicated setups, no local installations, just open and start coding. To get started, I'll log into my Google Drive, navigate to the folder where I want to work, and create a new Colab notebook. Once inside, the first step is to paste and execute the initial cell, which takes care of installing any necessary Python libraries. These are the tools Deepseek R1 suggested for handling the dataset and rendering the interactive map. After running this, I'll move on to the next steps. The process is simple. I'll add new code cells one by one, copy Deepseek's generated output, and execute the code in sequence. This allows me to monitor each step carefully, ensuring that everything runs smoothly. If there are any errors, I can debug them in real time without disrupting the rest of the workflow. One of the advantages of using Colab is that it provides a fully functional Python environment with pre-installed libraries, built-in GPU support for more demanding tasks, and seamless integration with cloud storage. That means even if you're not a professional programmer, you can still follow along and experiment with AI-generated scripts without needing a powerful computer. Now, let's see how well Deepseek's code performs. Will it generate a flawless interactive map, or will we need to tweak something? Let's find out. Analyzing the results. And just like that, we have a fully interactive map. With just a few lines of AI-generated code, we now have a dynamic visualization of the 20 most visited cities in the world. Each location is accurately plotted, and with a simple click on any point, a small pop-up appears displaying the city's name, its global ranking, and the estimated number of visitors. But here's something interesting. Deepseek R1 went a step further and automatically included the year of the data, ensuring transparency about when the visitor counts were recorded. That's a detail I never explicitly asked for, yet it improves the accuracy of the visualization. Now, while the map is already functional, I want to make it even clearer and more visually appealing. To do that, I'll apply color-coded markers based on city rankings. The top 5 most visited cities will be highlighted in red, making them stand out instantly. The next 5 will be in blue, the following 5 in green, and the last 5 in yellow. This simple tweak will make it much easier to spot trends and identify the most popular tourist destinations at a glance. Deepseek R1 instantly understands my request and generates an updated version of the code with the necessary modifications. I copy and paste it into Google Colab, execute the script, and within seconds, the new color scheme is applied flawlessly. Now, instead of a sea of identical markers, we have a clear, structured, and easy-to-read map that enhances data interpretation. This level of automation is a game changer. Instead of spending hours manually formatting and debugging, Deepseek R1 speeds up the process dramatically. But we're not stopping here. There's still more to test and explore. What happens when we challenge Deepseek with even more complex tasks? Stay tuned to find out. Final thoughts before AI models like Deepseek R1. Tasks like this required extensive manual effort, finding data, organizing it, and coding everything from scratch. Now, with just a few prompts, we get fully automated solutions. But how does it compare to ChatGPT when dealing with more complex challenges? That's something we'll explore in future videos, so be sure to stick around for that. That's it for this test. Deepseek R1 delivered impressive results. If you have any questions or ideas for future AI challenges, drop them below. Don't forget to subscribe for more AI experiments, and I'll see you in the next video.